en MP3.
Hello everyone! In this project we are going to demonstrate the intermediate axis theorem, also known as the tennis racket theorem. For our experiment we will use a ping-pong paddle which has three different principal moments of inertia because its mass is not distributed equally in every direction. First, we will identify its three principal axes and then show how the paddle behaves when it rotates around each one of them.
These are the three principal axes of the paddle. Axis 1 goes along the handle. Axis 2 goes across the face of the paddle. Axis 3 is perpendicular to the surface of the paddle. Now, we will throw the paddle so that it rotates around each axis. As you can see, the rotation around axis 1 is stable. The rotation around axis 3 is also stable. However, when the paddle rotates around axis 2, its orientation suddenly changes during the motion. This unexpected flip is called the Janivetov effect, and it's an example of the intermediate axis theory.
Why does this happen? A rigid body can rotate stably around the axis with the smallest or the largest moment of inertia. In this case, small disturbances do not significantly affect the motion. However, the axis with the intermediate moment of inertia is unstable. Even a very small disturbance grows over time, causing the object to flip unexpectedly while it continues rotating. This behavior is explained by the equations of rotational dynamics and is known as the intermediate axis theorem.
The Earth is also a rotating rigid body with three principal moments of inertia. Fortunately, it rotates around one of these stable principal axes, which is associated with its largest moment of inertia. Because of this, small disturbances do not cause sudden change in this orientation. In the Earth rotates around an intermediate axis. Its rotation will become unstable, leading to continuous changes in the orientation. Such behavior will have major effects on the planet climate and overall dynamics. Thank you for your attention.